Hey guys, Mr. Bowman here. Today's learning objective is in yellow and we are learning to prove the sine rule. And I've written the sine rule down below in blue. That's what we're trying to mathematically prove with our equation or our example. So let's draw an example triangle. So here's a triangle. The characteristics of this triangle, it's a non-right angle triangle, because the sine rule won't work for right angle triangles. And we're going to start labeling the sides or the angle. So this internal angle we're going to call side A, which means the opposite we're going to call little a. This one here we're going to call internal angle B, which means the opposite will be little b. And this internal angle we're going to use big C, which means that will be little c. So we won't be focusing on the C's too much, because we're going to focus on proving the A and the B parts, but the same does hold true for C as well. So the first step we're going to do, we'll change pen color, we'll get into green. We're actually going to chop this non-right angle triangle down the middle there, and this actually has the effect of creating two right angle triangles. So that green dotted line, that's perpendicular to the base of this triangle. And we're going to call the height of this triangle, we're just going to call that H for now. And we are going to label our triangle, so that half is going to be triangle 1 and that half will be triangle 2. So we're going to start off with triangle 1 first. So we are using the sine rule. So we're going to start off with our right angle sine formula, and we're going to repeat that for triangle 2 as well. So we've got two sine formulas. We're then going to, for triangle 1, we're then going to substitute everything in. So B, that would be the hypotenuse. H over there, that would be the opposite. And down the bottom, that there would be the adjacent of that triangle. So we're going to substitute all our values in. So sine big A, because that's the given angle we're interested in, that's going to be equal to little h divided by B. And if we rearrange that, that's going to be B times sine big A. So we're going to stop there. We're going to shift over to the second triangle now. We're going to repeat this process. So again, so the opposite, that hasn't changed. That's still H. The hypotenuse, that's still up here. And the adjacent is going to be down the base of the triangle. So we're going to substitute in again. So it's going to be sine big B. That's the angle. The opposite is still little h. And the adjacent, the hypotenuse is little a. And when we go through and rearrange that, that's going to be sine, actually let's put the little a first. It's going to be little a times sine big B. And at this point here, this is when we get to our our important step. Hopefully we've noticed both of these are equations for H, which means we can equate them together. We can use our systems of equation skills to put them together. So that means little b times sine A, that there is equal to A times sine big B. From here, we're just going to do a little bit of algebraic rearranging. We're going to move this this times sine A to the other side as division. And we're going to do the same for sine B. So that will become division as well. So that's going to be B divided by sine big B, and that comes from this. And then it's going to be equal to A divided by sine A, which comes from the sine A on the other side. And what we got there is we got the first half, or the first 2/3 of our formula. A divided by sine A, B divided by sine B. And that there is our proof that using the right angle triangle rules, we can develop our sine rule, which applies to non-right angle triangles. So therefore, A divided by sine A, that's going to be equal to B divided by sine B, which will be equal to C divided by sine C. Hopefully you found this video on proving the sine rule useful. Let's get into heaps of practice.